Okay. All right. Number one, Vincent's already writing away. He's already got it figured out. What are you doing, Vincent?
I was actually labeling it.
Oh, okay. Did you have a thought on problem number one?
Do you plug in x plus 1?
That's well, you plug in, what would we plug in?
X, or negative 1?
Negative 1. You plug in what you would have divided by. Why do I not want to divide in this problem? Certainly find the remainder I could divide. Why do I not want to? Oh, it's too many zeros. That's too big of a problem, right? So I'm going to plug in negative 1. Plug in, remember, whatever number you would have divided by. So I'll plug in negative 1, and I'll get 3 times 1 minus 8 times negative 1 plus 9 times 1 minus 2. Remember, when you raise a negative to an even power, it becomes positive. So 3 plus 8 plus 9 minus 2. If I did my arithmetic right, what is that, 18?
Why do you go to plus 9?
Well,
oh, it is plus 9.
All right, everybody okay with that?
And would 18 be the actual remainder?
That's the remainder. So, had the question been, is x plus 1 a factor?
No.
The answer would have been no, it is not. Okay, number 2, find the zeros. This is the heart and soul of this whole chapter. All right, so here we go. How do we find the zeros? What are you thinking? What's going through your mind?
On P's and Q's.
I need to find my possible rational roots because this does not factor by grouping, right? Good grief, you got a 17 and a 15. That's not going to factor by grouping. So your PRRs are factors of 15 over factors of 1. So what do? Start putting them in, right, and see what happens. How about 1? I think 1 works. It looks promising. So 1 of my zeros is 1. Everybody okay with that? So now what?
Factor.
Look what's left. X squared plus 2x minus 15. Right? Which you certainly can factor it if it factors, or you can always use the quadratic formula if that works best for you. But I think that does factor. So the other 2 zeros are negative 5 and 3. Everybody okay with that? The next one has you working backwards. They give you this. They give you the roots and say, okay, what's the equation that generated those roots? Well, 2 things.
X minus 1.
First of all, I told you on Friday, or whatever day that was, we talked about Descartes. I told you that imaginary roots never, ever, ever come by themselves. So you cannot have just 3i.
That'd be plus or minus.
There is also going to have to be the conjugate negative 3i. This is 0 plus 3i. You must also have 0 minus 3i. They never, ever, ever come alone. So notice, it's not listed on there. You're supposed to know if 3i is a root, so is negative 3i. So now we're going to work backwards, and we're going to build the factors that generated the roots. Going backwards now. So what would be this factor? X minus 1. X minus 3i. X plus 3i. Now multiplication is commutative and associative, so it really doesn't make any difference what order you do this in. But I would suggest that you always start with the imaginaries, because since they are conjugates of each other, when you multiply them, a whole bunch of stuff's going to cancel out. So when I FOIL those cancel, of course, that's what it means to be conjugates. And then you got to remember what's I squared. So this becomes x squared plus 9, which still needs to be multiplied by the x minus 1. And there is your polynomial that has these as roots. Any issues with that, Vincent?
Do we have a quiz or a test this week?
Oh, yes, we do.
And it's on Discord.
Yes. We will not have a test this week, but we will have one more big quiz. Our test will be like a week from today. Or maybe a week from tomorrow, I don't know, we'll see how it goes. Okay, next. Okay, we're gonna write an equation for the graph, so it's kind of like what we just did. Only there's some additional information, is that a 3? There's some additional information given by the picture. Clearly, we can tell that our factors would be what? That's a 0, so our factors would be x plus 2, x minus 1, x minus 3.
Square with the x minus 3.
But the x minus 3 is what we call a multiple 0. It happens twice, and our picture tells us that because it's a bounce-off point. These zeros only happen once because the curve just slides right through. You do not have to multiply that out. Everybody okay with that? This 0 is said to have multiplicity 2 because it's squared. These are what are called single zeros or simple zeros. They only happen once. Did we already do number 5?
Yep.
Okay. Number 6. The length of a picture is 5 feet more than its width. Stop right there. How are you going to set that up? The length is 5 feet more than the width.
Go put 5 plus x.
So if we let the width be x, the length would be 5 plus x. The area is 66.
So that'd be 5 plus x times x equals 66.
Length times width is area. Find the dimensions. So we're going to solve this equation. It's a quadratic, so you are allowed to use the formula if you want. This one does factor. Your roots come out to be negative 11 and 6. Obviously, negative 11 is not going to work, right? Can't have a width that's negative 11. So what are the dimensions of the picture?
Width is 6 feet in length.
6 by 11, yeah, 6 feet by 11 feet. All right. Okay, everybody warmed up? All right, let's open up our books to page 234 then. but really not, because we kind of already talked about most of it. Let's just formalize it a little bit. Page 234, number 10. We have already talked about this kind of problem today, but this one adds a little bit more. So I wanted to make sure we touch base on it before we do it for homework. It says write the equation that has these roots. What's the first thing you notice? You're not going to have 1 minus I without also having 1 plus I. So I would write that down. This is going to be a 4th degree polynomial, right? What are the factors going to be? What am I going to be multiplying? X plus 1, x minus 2,
X
oh,
minus.
here we go, x,
Plus 1 minus I.
now watch it, now this came over and you made it x plus 1, so what's this going to be? X minus 1 plus I, and what's this one going to be? X, bring it over, it's going to be x minus 1 minus I. Now listen, kids, absolutely none of you has an issue making this x plus 1, right? It's the same idea. Bring it all over with the x. This becomes x plus 1, this becomes x minus 1 plus I. X minus 1 minus I. You gotta FOIL all this together. Let's do these first. I know they're the scariest, but they're also going to be the nicest, because a bunch of stuff is going to cancel if you do it right. So here we go. I'm going to take this, times all 3 of those, this, times all 3 of those, and that, times all 3 of those. So here we go. By the way, math league tomorrow, do not forget. Tailgate. Please come and have Dr. Greer's sausage. All right, here we go. What cancels? Hopefully a whole bunch of stuff. I have x squared minus 2x. Those cancel. Those cancel. What's negative I squared? 1 plus 1. So that's what I got when I FOILed those together. Now let's FOIL these two. That's going to be x squared minus x minus 2. Now what? One more time. FOIL, here we go. So if I have done it right, I think that's right. Anybody wondering about any of that?
sure it's not 6x?
Oops, no, I'm not.
No,
It's supposed to be 6x. Okay, did I miss a sign? I got a negative 2x there. Where did that come from? No, that should be minus 2x there. Because it came from negative x times 2.
Oh, okay.
Jen, I can check my answer real quick, because if I take my answer and I divide out one of the roots, I should get a remainder of 0, right?
Mm-hmm.
So if I don't, I get, so I'm good. All right, any other question about that? All right, the next one I want to take a look at is number 14. I'm not going to do this, well, actually, I can't because I'm not going to multiply it out. But number 14 says that I have x equals negative 1, but it has multiplicity 3. I just told you what that meant. What does it mean if it has multiplicity 3? It means it's cubed. So this would be x plus 1 cubed. And then x equals 3 has multiplicity 1, so that would be x minus 3. So this would be your polynomial, not multiplied out, but that would be your polynomial, right? That's all that means. Do not be confused by it. All right, and then I want to look at number 28. Says find all the zeros and write a linear factorization. Do not let the vocabulary scare you. Find all the zeros. I've already done that today. We've done it a lot. How do you find the zeros of this? It does not factor by grouping. So, what are my possibilities?
Factors 69.
Yeah, there aren't a whole lot of those. Plus or minus 1, 3, 23, and 69. That's it. There aren't very many. So anybody see one that works? What? Check this out. Think about Descartes. Remember, Descartes' a tool. Use it, parts of it, don't use it, whatever, it's up to you. Think about letting x be a negative number. What's going to happen if you put a negative number in here? What's this?
Negative.
Negative?
Negative.
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 Negative. Negative. Any sign changes in that? So what does that tell you about trying negative numbers? Don't, right? It's not going to work. So let's try 3 works. Yesterday at Open Gym, we were noting that it really is, these are better to do as a group because you don't have to waste much time finding roots. But you got one, x equals 3. What's left? X squared minus 7x plus 23.
You have to use a quadratic formula.
That does not factor So we'll use the quadratic formula. So x equals negative b plus or minus b squared minus 4 times a times c. Oh boy. What's going to happen? We're going to get imaginaries, which is not the end of the world. What is that under there?
Negative 43.
49 minus
Negative 92.
92. Is it negative 43? So it's, does someone match that?
Yeah.
So what are our zeros?
X
One of them was 3,
and plus or minus the
and then, yeah, and another one was 7 plus I root 43 over 2, and 7 minus I root 43 over 2. Now, normally I wouldn't write those separately, but the reason I wrote them separately this time is the direction said, okay, find the zeros and then write a linear factorization. Now, I'm doing this because that's what the direction said. I am not going to have you write a linear factorization with hideous roots like these, but that's what the direction said. So what do we mean by linear factorization? We mean put these into factors. So what would this factor be? X minus 3. This one would be x minus 7 plus I root 43 over 2. And this one would be x minus 7 minus I root 43 over 2. There is your linear factorization. I would prefer, if I have to write the factors of this, I would prefer to leave it like this. But that's not linear because this is a quadratic, right? That might be the direction that says do that. Yeah, look at the directions for number 37. Write the function as a product of linear and irreducible quadratics. So this would be what you would do in problem 37. This is an irreducible quadratic. These are your linear factors. Yucky. Okay. All right. Anybody have a question about anything in homework assignments that we haven't gone over yet? Anything homework-wise that you haven't been able to sort out? Section 2.4, 2.3. They kind of all blend together. Anybody, Jamie?
On 4, number 11, I didn't know how to write the remainder and not a remainder division.
So did you do that synthetically or long division?
Yeah, I did see that.
Okay, that one's a little tricky. Because you've got 5x to the 4th minus 3x plus 1 over 4 minus x, which is the same as negative 5x to the 4th plus 3x minus 1 over x minus 4. Did you make that change? I don't know if it makes a difference or not. I would. Let's see if it makes a difference. So we get 4, and then be careful here, we got some zeros. Oh gosh, this is getting quite large. I got negative 1269, is that what you got?
No. I got 709. Well, I didn't get 317, I got 117.
Did you get 320 here?
I got one. That one. Yeah, that's really wrong. I'm sorry.
So anyway, the question was, what do I do with the remainder?
Yeah.
The remainder just gets put over whatever you divided by. So this would be negative 5x cubed minus 20x squared minus 80x minus 317 plus negative 1269 over x minus 4.
Well, I didn't know how to do it. Don't you have to divide it again with the cube? Don't you have to do systematic division twice since it's a cube?
No, because this is just a division problem. It just says divide. If I were looking for roots, well, first of all, I wouldn't ever divide this because I didn't get a 0. So I would never do anything with this, even if I were finding roots. But if I were finding roots and this came out to be a 0, then I would take what's left and try to break it down further. But this is just a division problem. So we just stop after we do the division. Okay, all right. Yes,
When you're
Grace.
finding a lower bound with like the alternating signs, it has to be positive, negative, right? It can't be like two negatives in a row.
Yes, that's right. It has to be alternating. Now, sometimes when you divide, Grace, you're going to get, you know, two negatives and then a positive and whatever, and that's perfectly okay. It just means the number that you found isn't a lower bound. Yeah. All right, anybody else have a question about something? Robert?
On the homework for tonight, I'm just kind of wondering what we need to do for like question 3.
Which one?
Number 3. Or like, and number 1, either one.
Foil.
Just FOIL them out and then find the zeros.
No, the zeros are given.
Yeah.
You have the factors. So like, for number 1, the zeros are 3i and negative 3i.
Okay.
Yeah.
So they just want you to put it in the FOILed out form? Okay.
Yeah. They want to find, they say, what are the zeros? The zeros are right there.
Yeah.
I mean, you can get those right from the factors. Now, did you notice in problem number 1, Robert's looking ahead, they asked you for the zeros and the x-intercepts. Now, wait a minute. I thought those were the same thing. Under what circumstances would they be different? Imaginary numbers, exactly. Zeros can be 3i and negative 3i, but are those x-intercepts? No. So if you had a problem where you had plus or minus 3i, 4, and 2, and those were your roots, all of these are zeros, but only these are x-intercepts. They're the only plottable ones. All right, you can go ahead and get started on this then, section 2.5. And for your planning purposes, we will either have a test before IRT or right after IRT. Next week, we go to IRT on Tuesday. So it'll be a Monday or Wednesday.